Hello everybody, it is me, your chemistry tutor, Peter, and today I'm going to be helping you understanding Hess's Law, and I'm going to be doing 5 questions ranging from super easy to I don't even want to do chemistry anymore, so let's get into it. So first, we're going to do this one. By the way, when I'm doing these equations, I'm going to be establishing some laws and rules. Just try to follow me and just see how I do these things and then just apply it to your knowledge. There's going to be some resources that I'm going to link in the description of this video and in the group chat. Also, use the Clueless Freshman Google Drive. If you have any skills that you need help on, definitely DM me, ask me to make a video on it because I really want help. Alright, so let's get into it. So, this one. So the first rule of Hess's Law, or the first step in applying Hess's Law to these equations is what I like to do is we're going to find an exclusive element or compound in only one of these equations. So what I mean by that is alright, just carbon, right? It's not in the second equation. By the way, if it's like 2 CO2, like the carbon's in here, that doesn't count, right? You can also, CO2, the 2 CO2s here, they can't be found over here. So you could start with either one of those. I want to start with 2C. Up here, it's asking you for 1 carbon, so we're going to divide this whole equation by 2. So we're going to divide this by 2. And so that would be C plus 1.5 O2 CO. Alright, don't be afraid of this. Let's keep it going. Alright, so over here we got our carbon, but yeah, okay, none of these really need to do anything. Alright, then we're gonna go with the second exclusive, which is gonna be the CO2. So up here you only need 1 CO2, so once again you divide this by 2. So CO2, 1.5 O2 plus carbon monoxide. Alright, so yeah. So now let's check for what we have. Remember, for Hess's Law equations and applying that, the stuff that actually goes into the equation has to be on the right side. So this is on the reactant side. This is on the product side. For stuff that you don't need, and by the way, here's the thing about canceling out items. So if a molecule is on one side and like the same molecule in a different equation is on the other side, they like minus each other. So these CO just cancel out because they're on different sides. And since these ones aren't on different sides, you actually add them together to get that O2. And so once you add all of these, so you just take these divided by 2 and add them together, you should get negative 393.51 kilojoules. And yeah, let's move on to the next one. Alright, moving on to the next one, which is a little bit harder. I'm also going to introduce like a little bit like a new, not a new concept, but a new understanding of how stuff cancels out. So let's first just focus on whatever element or molecule is exclusive to one equation. So that's CH4 over here. You could also start with water over here, but I like to start with CH4. So up down here you only have 1, up here you have 2, so let's just time all of this by 2. But also CH4 is supposed to be on the reactant side, so you're just going to reverse the sign of the energy. So this should be negative 890.32, and since we're also timing it by 2, we just have 2 times 2. So it's 2CH4 plus 4O2 equals 2 CO2s and 4 waters. Okay, we got that. Oh my god, hold up. Alright, that's your equation. And then, okay, so now we have that and we have that over here, right? We just need to find the oxygen and the CO. Over here we have CO2, but we need CO, so that's probably on the other equation. Let's just write the other equation and just add it together. So 2CO2, 2CO2 equals 2CO plus 2. So let's look at this together. So we got CO, we got the 4 waters on this side, and we got the CH4. Let's just see what cancels out. So this, okay, so the reason why this cancels out this is because these are on opposite sides. So they kind of like minus each other. So this minus this one. And that applies to even stuff that we're gonna have in the equation. Since this, well, since we have more like than we need in oxygen, we're just gonna minus like one coefficient. So basically this, the 4O2 up top. Why is my pen not working? The 4O2 up top minuses the O2 at the bottom because they're on opposite sides, right? This is in the product, this is in reactants. So then that should give you 3O2, and that's exactly what we need. So what you're gonna do is you're gonna calculate this one, and then yeah, you just add this one. So in total, you should get negative 1,214.7 kilojoules. Yeah, let's move on to the next one. All right, let's move on. All right, so same as before, look for the exclusive. So let's divide this whole equation by 2. So 2b plus 3 over 2 oxygen gas equals just 1 diboron trioxide. I think that's what it's called. Why can't I write 3 dot? Okay. So okay, let's skip this one and let's go for this one because I see an exclusive right here. That needs to be flipped. So I also need to annotate 5, 5, 2. This one's gonna be flipped, so it's gonna be plus. So let me just write that. 2 B2O3 plus 3 waters. Alright, let's just have a quick check. This one is up here, that's good. This one's up here, we're good. So let's see what we can cancel. This one gets cancelled because they're on different sides, and we can't really do any more. So let's quickly write the next one. Oh, okay, or we can just, yeah, let's just look at the next one. So the next one, we're gonna need the hydrogen gas, but there's 2 over here and there's 3 up here. Also, it's on the wrong side. So one, we need to reverse this. So it should be 71.66. And we also need to times this whole thing by 3 over 2, right? Because 2 times 3 over 2 is 6 over 2, and that's 3. So 2. And let's quickly write that. So that's H2 plus 3 over 2O2 plus 3H2O. Alright, so let's see what we have and what we can cancel. Obviously, the hydrogen gas, we got it. We can cancel out the waters because they're on different sides. Now for this one, the O2s, you obviously cancel them out, but the reasoning behind that is because since these ones are on the same side, they add together to form 6 over 2 O2, and that's basically 3. But since that those ones are on this side and that this O2 is on this side, that's basically 3 O2 minus 3 O2, which is 0, so cancels out. Alright. Actually, press Control Z. And in total, your equation should be, let me write this out real quick. Negative, ooh. Why am I being reconnected? Okay. Oops. Okay, my whiteboard reconnected right there. Should negative 2509.1 divided by 2 plus 2147.5, and then you minus this one but times 3 over 2, and you should get this. Alright, moving on to the next one once more. Right before the one that's super hard, and I'm gonna do this one, which should be pretty easy, but kind of hard-ish. Alright, so let's do this one. So, like I said before, look for the exclusive first. However, this is on the wrong side, so reverse it. Alright, and so that should give you CH4 equals 2 hydrogen gases plus carbon. Alright. Okay, and so yeah, let me look up here. Yeah, it only asks for 1 CH4. And then down here, we got HCl. It asks for twice the amount here, so we times the whole thing by 2. And then you should get, yeah, it's already on the right side, so let's just do HCl. That's it, and then down here, we only need one of these, so just write the equation again. 2 chlorine gas, and then I actually wrote the thing twice. My bad. Alright, my bad. So I should get CCl4. And now let's cancel out stuff that we need and stuff we don't. So let's see what we do have. We have that, and then we do have CH4, right? And obviously we have this one. These are all on the right side. We just need the chlorine gas, but let's just see what we can take out first. So since carbon over here, like these two carbons, this one is on products, this one's on reactants. Since they're on different sides, they cancel out each other. If they're on the same side, you add them together. So these cancel out. Same thing with hydrogen gas over here. And since these two chlorine gases are on the same sides, you add them together, and that's why you get that level 4 chlorine gas. So up here in the energy, you just add them all together. So that should, let me just write the equation. Positive 74.85 plus 2 times negative 184.6, and then you also minus that by 135.4, and your answer should be negative 429.75 kilojoules. Boom. Let's move on to the very hard one. Alright, finally, it is the final question. Our final boss, I guess. And it's probably going to be the hardest one of this video. So I went ahead and asked GPT to generate me a question, and this is what it put out. So let's do it together. First, obviously, I don't need to tell you this. Look for the exclusive. So glucose here is the exclusive, but we're going to need to reverse that. So this is going to be a plus. So let's rewrite that equation. And then that equals 302. Actually, let me write this a little bit smaller. Plus 6H2 plus 6C. Alright. So, not much we can do here. Let's look for another exclusive. Water. Down here you have 1, but up here it asks for 6. So we're going to time this by 6. Cool beans. Water is already on the same, yeah, it's on the right side, so we don't need to do anything besides times it. Here. And so it'd be 6H2O. And over here there's 3O2. Oop. But there's 6 Yeah, right. Okay, that checks out. And then up here, let's just put this here. I don't know how to do this yet. Let's just check. All right. So let's just quickly check what we have, what we need, and so what we're gonna need to multiply these by down here. Okay. So we have our glucose up here. One. Let me do it in red. Oop. Right here. We have our water. Yeah, let's see what we can take out. So, since the hydrogen gases are on different sides, they cancel out. That makes sense. And we need 6. Okay, we need 6 CO2. So we're gonna times this by 6. Should mark that. Mark that by 6. So it should all be 6. By the way, because CO2 is an exclusive. So we got the CO2. It's on the right side. Yeah. Now let's see what cancels out and what does. So now the carbons cancel out. We don't need that anymore. And this is the tricky part. So since the 3 O2s are on different sides, they actually cancel each other out. And so that leaves us with 6 O2, right? Because it's on the right side over here and this cancels out. And so that's the whole equation. And so what you're going to have to do is then you're going to have to do that. So, yeah, and that actually gives you this answer right here, which is like, it's like, 2,000 something kilojoules. And that was it. Obviously, I'm going to like post all of the resources in the video's description. The chem quizzes that I did in the beginning, these over here, that's a whole site, it's obviously called Chem Quiz. You can find that in my Google document, or I think also, like I said in the description of this video. The final question was only in ChatGPT, but by the way, ChatGPT is good at making its own equations and then giving you the answer, but if you took one of these equations from here and then asked GPT to solve it, it's not as good from experience. So yeah, I hope you found that educational, and I hope you learned how to do Hess's Law, and that was the video. Thank you for watching.